All right, hi there guys. Today we're going to look at still solving some systems of equations. And as you recall in our last video that a system of equations is just where I have two or more equations that have the same variables and kind of deal with each other. So today we're going to learn a different method to solving them. So in our last lesson we solved them by graphing. So today we're going to use substitution. So substitution is a method of solving systems by substituting, I know, great use of words, right? By substituting the equations within, so kind of we're still using both of them, but within another. Okay, so the first thing we really kind of do is we're going to follow these steps all the time when we're using substitution. And we'll get to the point in a couple of lessons of determining if we'd rather use substitution or if elimination would be better, but we're not there yet. So step one, I would solve one equation for either x or y. It doesn't matter, so we want to pick the easiest way to do it. So then the second step is I substitute that expression or that equation into the other equation and then solve for that variable. So then that third step is I'm not quite done, is I then have to substitute and then solve again. So let's look at a couple of examples. Whoops, let's look at this first example. So our first step was to solve one of my equations, and it doesn't matter which one we pick first, but solve an equation for one of my variables. So I see that this first equation is already solved for y. So now I know that the second step is I go ahead and I substitute that in my second equation wherever I see a y. So I end up with 4x minus 1, and then I substituted into my second equation, which was 2x minus 5. So from here, I see that I just have a couple of linear expressions, and I want to get all of my x values to one side. So I subtract that 2x. And then I'm going to add my 1 to both sides. So I end up with 2x equals a negative 4. So divide by 2. So x equals negative 2. Well, I'm not quite done yet. So I have to go ahead and do that final step, that step 3 from above, is where I substitute this back into one of my equations. So the cool thing here is it doesn't matter which equation I pick to substitute it back into, it'll work for both. So I like to pick the easiest one, and in this case they're about the same. So I'm going to go ahead and do that top equation. So I have y equals 4, and I always use parentheses when I substitute that negative 2 minus 1. So y equals negative 8 minus 1, so y equals that negative 9. So to write my final answer, I'm going to go ahead and use my coordinate point and have my x as negative 2 and my y was negative 9. So let's go ahead and look at one more example that's kind of a different one. Let's look here at number 3. Okay, so the first step was to solve one of my equations for one of my variables. And again, this one has kind of already been done for us because I have y equals. This could be x equals, it doesn't matter. So now since one of my equations is solved for one of my variables, I go ahead and I substitute that in. So I now have 3x plus 8, and I'm going to substitute right here my x plus 9. And again, always use your parentheses, equals a negative 5. Well, so now I can just distribute this 8, so I end up with 3x plus 8x plus 8 times 9 is 72 equals a negative 5. So from there I combine my like terms, 8, 9, 10, 11x plus 72 equals negative 5, and then I subtract. So 11x equals negative 77, so x equals a negative 7. So from here, I can pick either one of my original equations to plug this x back into, and I'm going to go ahead and pick that top one just because it's an easier equation to deal with. It's a lot smaller. So now I have y equals, always use parentheses when substituting. So I end up with y equals 2. So I want to go ahead and write my final answer as my coordinate pair. So I've got negative 7, 2. So now I want you to spend some time and work through these other examples, and I'm going to go ahead and post these solutions in Classroom as well so that you can see what the rest of them really should look like before you dive into that homework for this section.